क्या जिंदगी है, रिकॉर्डिंग इन प्रोग्रेस। एक तो लैपटॉप लिया इतना महंगा, इसके पैसे पूरे कर रहे।
अभी पैसे पूरे नहीं हुए
क्या हुए से?
4,000 नहीं है। आ गए।
अरे 2,000 दिए थे ना। ये 3200 को कितने का है पता नहीं।
उसका पैसा भी निकला कि नहीं निकला।
कहाँ निकला ऐसा है। हम तो पढ़ाते हैं और पता नहीं 2-2 महीने तक फीस। हम तो फ्री में पढ़ाते हैं।
ये गरीब बच्चों को ना पढ़ना, अमीर बच्चों को पढ़ना, जिसके पास पैसे काफी अर्निंग हो रही
किधर है?
देख के पढ़।
हमें तो जो मिलते हैं वही गरीब होते हैं। हेलो। अस्सलाम वालेकुम।
Walaikum Assalam, sir.
How are you, man? Okay,
Alhamdulillah, fine,
so
sir.
any question from previous lecture?
No, sir.
Are you doing past papers, Anas?
Just going through topical past papers for now.
So, is it easy
Yes, sir. It's moderately easy.
but still tough, huh?
Yes, sir.
Then what to do?
मैं मिठाई इतना नहीं खाता है।
We'll start
So far,
organic chemistry now.
okay, so far, how many chapters that you have gone through past papers?
Basically, all the inorganic chapters.
Lattice energy, Gibbs free energy, electrochemistry, and
Yes.
transition. Which chapter you feel most difficult from past paper?
I would say that transition elements.
Transition. Okay,
Yes.
but that is the most easiest one.
Like the crystal field theory, that's still a bit confusing to me.
We will repeat one day, okay? Here, remind me.
Okay, sir.
Okay, so organic chemistry. I have sent you the recorded lecture.
Yes.
Have you gone through?
Yes, sir.
Okay, organic chemistry. So here is the first chapter is benzene, aromatic hydrocarbons. Okay, clear?
Yes, sir.
Okay, so first we need to learn about the benzene. We know that its molecular formula is C6H6. Okay, if we draw the structure formula, so we can write like this. And each carbon is having one hydrogen. Is it clear?
Yes.
That's called benzene, C6H6. You can see here, here is a double bond, then single, then double, then single, then double bond. Got it?
Yes, sir.
Okay. We know that benzene is an aromatic hydrocarbon, okay? Aromatic hydrocarbon. Now, what we mean by aromatic? It was believed that those compounds having some aroma, some fragrance, okay? It was the belief of the ancient people that any compound having some fragrance, aroma, they call those compounds aromatic. Is it clear? So on the basis
Yes,
of
sir.
aroma, they were calling compounds aromatic and non-aromatic. Now, but it was not like definition, exact definition, okay? So currently, the exact definition that we have about the aromatic hydrocarbons, it needs to fulfill these four principles, these four parameters, okay? These four criterias. Like suppose a compound must be closed, must be closed. Must be closed means must be cyclic in nature, okay? Cyclic in nature. It shouldn't be open. Like this is a cyclic structure. This is a cyclic structure. This one is closed. This one is closed. But this one is open. If I'm writing CH3, an open structure. If I'm writing CH4, an open structure, okay? So, according to aromatic compounds, the first criteria that the compound must be cyclic or closed in nature. Is it clear? Second criteria.
Yes, sir.
Okay. Once the compound is closed, cyclic, the so compound must be planar in nature, okay? Planar means all the species, all the atoms must be present on one axis, okay? On single axis. It shouldn't be placed in two or three axes, okay? Like X, Y, Z. It should be either on Y axis or Z or X axis, okay? So that's called planar. And we know that organic chemistry, the backbone is carbon. So definitely you will judge the compounds on the basis of carbon, okay? So a carbon is planar when it is sp2 hybridized, that we know. Is it clear? So each carbon must be sp2 hybridized. When it is sp2 hybridized, then it would be planar. Is it clear now?
Yes, sir.
Now the third point is, third point. Okay, it should possess, it should has uh, conjugation, okay? Conjugation. We will explain all these points one by one. Conjugation are, okay, simply we can say compound must possess resonance, okay? Conjugation or resonance, okay? And conjugation or resonance because of the alternative alternative double bonds. Clear? Last point, fourth point. It must follow, okay? Must follow. What to follow? The Huckel rule. Huckel's rule. What we mean by Huckel's rule, okay? Huckel's rules means 4n plus 2 is equal to pi electrons. You need to find out the value of n. When the value of n is 0, 1, 2, 3, and so on, it means that Huckel rule has been followed. Okay? But if value of n is coming in fraction like 0.2, 0.3, 0.5, then it means that the rule is not followed. Is it clear? So we need to check all this checklist. If any compound is complies with this checklist, then you would say the compound is aromatic in nature. Is it clear?
Yes, sir.
If any point is missing, any point, suppose 3 points, okay, in the checklist complies, one is what is not complying, okay, it means that it's the compound is not aromatic in nature. Let's see. Let's do some examples. Suppose we have this compound. You can see here. Okay, let's make four bonds because each carbon belongs to should have four bonds. Okay, to complete its valency. So I'm putting CH2, 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 CH2 here. This compound is basically a cyclohexane. Cyclohexane. Okay, it's cyclohexane. Now, what do you mean by cyclohexane? Do you think it is aromatic? Let's see. First point. Do you think it is a closed cyclic structure? What do you think?
Yes.
Yes. So let's take yes. Second point. Okay. Do you think each carbon is sp2 hybridized?
No.
No. So it means that this compound, leave it. This compound is not aromatic in nature. Got it now?
Yes, sir.
Let's see. Okay. I want to move onward. Okay. I want to talk about the conjugation. Okay. Let me explain this first point. We have different types of double bonds, okay? We have different types of double bonds. Double bond maybe exist in the form of what? Isolated double bond. We can call it isolated double bond. We can call some bonds in which the alternative double bond, alternative double bonds. And some double bonds are called allenes. So what we mean by all these double bonds, let's see. Isolated double bond means what? Suppose you have a carbon-carbon double bond, then carbon-carbon single bond, then single bond, then single bond, then double bond, then single, and so on. So here you can see in this structure, the double bond is far away from each other, okay? You see, okay? So there is a gap between the double bonds, okay? So when we have four double bonds, okay, far away from each other, okay, that's called isolated double bonds. Okay, alternative double bonds. You can see CC double bond, then single, then double, then single, then double, then single, then double. You can see here the double bond is present, okay, in alternate position. Is it clear now? Clear?
Yes.
Double, single, double, single, double, single, double, single, double, single, and so on. That's called alternative double bonds, okay? This is called what? Isolated double bond. Okay, allenes means what? Suppose you have a CC double bond, then CC double bond again. So consecutive double bond. If we have consecutive double bonds, okay, then it's called allenes. This such kind of double bonds called allenes. And when it is present, okay, after an alternate fashion, then it is called alternative double bonds. But the double bond is isolated, okay, then far away from each other, then it is called what? Isolated double bond. Is it clear? Is this point is clear?
Yes, sir.
So in aromatic compounds, we must have this type of bonds, alternative double bonds, okay? If we have this type of bond, we have this type of bond, then compounds, okay, we can say they are not aromatic, okay? Because for aromatic, the double bond must be present in alternate fashion. Why? Why it is necessary that it should be in alternative fashion, okay? Because we are talking about the conjugation, okay? Now, what we mean by the conjugation? Conjugation means the movement or migration simply. Movement or migration of the double bond. Of the double bond simply means pi bond, pi electrons, okay? Because double bond called pi bond. Is it clear now? So the
Yes,
movement
sir.
or migration of the pi electrons means pi bond means double bond, okay? from one position to another position within the molecule, okay? Within the structure, within the molecule. If pi electrons can move from one point to another point within the molecule, then you can say, okay, the molecule is showing conjugation, because conjugation means this movement of pi electrons or pi bond or double bond from one point to another point. Suppose here you can see in this example, suppose this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, 7, and 8. Here we have a double bond between carbon 1 and 2. So we can say that this bond, if move from this 1, 2 position to 2, 3 position. So you can see, okay, the double bond or the pi electrons or the pi bond is changing its position, okay, within the molecule. So this changing of position of the pi electrons or the movement of pi electrons from one point to another point, okay, another location within the same molecule. This migration is known as what? Conjugation. Is it clear now? Conjugation.
Yep. Yes, sir.
Now, the thing is how this conjugation is taking place. What is the main criteria? What is the main principle, okay, that allow this migration, okay? So is it possible in every pi bond electrons or double bonds that they can migrate? Because we have the pi electron of the pi bond in isolated double bonds in allenes also. So is because pi electrons are also there, so is it possible for them to move within the molecule or not? No, not possible. Okay. So we are studying now the conditions, okay, in which this migration is possible. Okay. Let's see. Now, when you have the double bond in alternate fashion like this, okay, I'm just trying to complete the valency. Here you can see CH. Here it has 3 bonds, so let's make one bond. Let's make another bond. Done. Okay. The pi electrons are the pi bonds, okay? They feel free. They feel free and they feel that they can move now if the pi bond is having another pi electron in alternate way, in alternate fashion, okay? Is it clear now?
Yes, sir.
So only in that case, the pi electrons can move. Let's see. This pi electron wants to, let's suppose carbon 1, 2, 3, and 4. This pi electron wants to move from 1, 2 position to 2, 3 position, okay? Is it possible or not? Yes, it is possible, okay? Because this moment of migration is supported by the pi electron here in 3, 4 carbon. How? Let's see. When this electron moves, you see, when this electron moves here, pi electron is moving towards carbon 2 and 3, okay? So by doing this, what will happen? Focus here now, okay? This carbon is having 4 bond, 1, 2, 3, 4, happy. 1, 2, 3, 4. Each carbon is having 4 bond, but because of migration, what will happen, okay? This carbon is going to be suffer. Why? Because it has already 4 bonds. So now another pi electron is coming here, want to form a bond here. So by doing this, how many bonds this carbon will carry? You can see 1, 2, 3, 4, 5, which is not possible. Is it clear?
Yes, sir.
So what will happen? This carbon 3 request carbon 4, okay, take this pi bond, pi electron towards itself. Okay, fine. Is it clear now? So by doing this, you are getting a new structure. You can see here, I'm drawing a new structure here. Carbon 1, I'm drawing like this. Carbon 2 is here. Carbon 3 is here. And carbon 4 is here. Now focus, okay? Uh, you have removed the pi electron from carbon 1. So now it is left with 3 bonds. You can see here, 1, 2, 3. And you know that carbon with 3 bonds, when electron has been removed, it carries what charge? Positive charge
Positive
because
charge.
electron has been removed. Now look at this carbon, okay? Carbon number 2. Nothing happened to this because before it has 4 bonds and still it has 4 bonds here. You see the pi bond move here. But look at the carbon 3, okay? Before it has 4 bonds, still it has 4 bonds, okay? Fine again for because this pi bond has been moved to this carbon, okay? So you can see this carbon is carrying 3 bonds, okay? But is this pi electron has been shifted to this carbon, that's why it will carry what charge? A negative charge because carbon with 3 bonds when electron move towards it that it can carry what negative charge, but carbons carry a positive charge when it has 3 bonds one electron has been removed. Is it clear now?
Yes, sir.
So you can see this movement of pi electrons within the molecule from one location, from one point to another point. Okay, this movement or migration is called what? Conjugation. Is it clear now?
Yes, sir.
And because of conjugation, okay, uh, you can have another structure for the given compound because actually this compound exist, okay, but because of the conjugation, okay, you can draw another structure for this compound, that is this one, okay. So so when we can represent, okay, more than one structure for a given structure for a given compound due to the because of the movement of the pi electrons, okay, isomerism, okay, like isomerism, that if a compound is represented by more than one structural formula, okay, due to the because of the different functional groups or because of the connectivity of the functional groups, like so on. You have studied that. That's called isomerism. You can't say that it is isomerism because here the isomerism, this type of different structure that you are getting after the movement of pi electrons within the molecule from one point to another point is called conjugation. Is it clear now?
Yes, sir. Clear.
So this is called conjugation. And conjugation happens when you have what the alternative double bonds, okay? In the vicinity, another pi bond, then the pi bond has the potential to move. Okay, let's move now. Otherwise, if it has isolated double bond, then they can't move. Is it clear?
Yes, sir.
Okay. So now again, what will happen? This because negative positive charges on are the sign of instability. Okay. So definitely it will go back, okay? In this way, carbon feels pain, so it will return this anion. Let's make another, again, the pi bond, okay? What will happen by doing this? This carbon will carry 5 bond, which is not possible. It will shift this pi bond towards this one. And again, you will get what structure? That backward structure. Is it clear now?
Yes.
So we represent these two structures by this arrow. You see this arrow. This arrow means that we can draw these two structures for the single molecule, okay? And so this arrow is called what? Resonance arrow. Resonance arrow. Is it clear now?
Yes,
If you
sir.
close your eyes and open, you will see this structure. If you close again your eyes and again open, then you will see this structure, okay? So you will be surprised, okay, which structure is the correct structure? No, both are the correct because both represents, okay, the same compound. Is it clear now?
So they both exist at the same time.
Yeah, both exist in the same time. Is it clear now? We usually draw this one. Is it clear? Mm.
Yes, sir.
Okay, so this is called what the conjugated structures, okay, are resonating structures, okay, and then we always draw another structure, okay, that represent both the structures at the same time. Okay, the structure is this. You see, again, 4 carbons I am trying to draw. Here you can see the dotted line. You can see here. Can you see here?
Yes.
Okay, I will show in benzene this thing. Okay, so you got what we mean by the conjugation. Is it clear now? That's one criteria where you can see the conjugation. Okay, let me show you one more. Suppose you have a double bond, and here you have a carbocate ions. Again, in this case, the double bond can move. Okay, that's another criteria. If a CC double bond is having another carbon in its vicinity with a positive charge, then the electron can move like this way. Is it clear now?
Yes, sir.
Okay, this is another criteria. So you done two criterias, okay, in which the pi bond can move. If a pi bond, there is a pi bond structures, okay. If in its vicinity it has another double bond, then the pi bond can move. If its vicinity, if it has the positive charge, then the pi bond can move. Is it clear?
Yes, sir.
Okay. Now, what we mean by the Huckel rule, let's apply here. Again, let me draw this structure. Okay, this one. Okay, so 4n. Let me draw it here. 4n plus 2 is equal to pi electrons. Okay, look at this structure. How many pi electrons are present here?
6.
One, two, three. These are the pi bonds. In each pi bond, we have two electrons. So two electrons here, two pi electrons here, two pi electrons here, to six pi electrons. Is it clear?
Yes, sir.
Okay, so 6 minus 2 is equal to 4, and 4 by 4 is equal to what? 1. Clear?
Yes, sir.
So n value is equal to 1. I told you that when n value becomes 0, 1, 2, 3, then it is called the Hakalul has been followed. Is it clear now?
Yes, sir.
Okay, now let's see. Come to the point, benzene. Can you see the structure? C6 at 6. This is benzene. Now let's do. Do you think the first point, is it cyclic?
Yes.
Okay, done. Second point, is it planar? The structure is planar?
Yes.
How do you know? You see,
Each
this
carbon is
carbon,
sp2.
sp2, 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 sp2. Okay, got that. Third point, is there is conjugation?
Yes.
Yeah, you see, CC single bond, then double bond, then single bond, then double bond, then single bond, then double bond. Oh, the alternate double bond. Is it clear?
Yes, sir.
Okay, done. Last point, Huckel rule. How many pi electrons here?
6.
So 6 again. It would be this. Followed or not?
Yes, it is.
So what do you think about benzene now?
It is aromatic.
Okay, done. Now, okay. Can I draw it like this to make it simple? Hmm?
Yes.
Okay, HH. I'm not drawing HH, okay? So you know that pi bond can move here, this will move here, this will move here. Okay, let me draw. Drawing. Can you see? I want to show here conjugation, okay? Okay, let's see. You see, this pi bond is moving here. So by doing this, this carbon will have how many bonds?
5.
So which is not possible, huh? So what will happen? This carbon will request this carbon, okay? Take the pi one. Okay, okay. Give it to me. It will move here. So by doing this, this carbon will have how many bonds?
5 bonds.
Which is not possible. So what will happen?
It will
It
give
will
its
shift
pi
this
bond to
pi
the
bond here.
other one.
Let's see.
Yes.
Let's see another structure. So this become double bond. Got it? This become double bond now. And this one become double bond. Is it clear?
Yes, sir.
Now you can see C6H6, C6H6, okay? But two different structures. Clear?
Yes, sir.
So it can again move this way, and this way to give you this big structure, okay? So you can see these, we are having two different structures for the same compound, okay? And these two structure that you are getting because of the movement of the pi electrons within the molecule. And when you have more than one structure, okay, for a given compound, because of the movement of electrons, then we can say these two structures are what? Conjugating structures or resonating structures. Is it clear?
Yes, sir.
Okay. Then we represent another structure that will represent both these structures. Okay, what would be that? Let's see. This. And I'm writing a circle here. Can you see this structure?
Yes.
Ahmad? This circle means that the pi bonds, six pi electrons are moving in this circle, okay? You can find here, it's anywhere you can find. Is it clear now?
Yes, sir. Clear.
This is called, okay, the resonating structure of these two. Clear?
Yes, sir.
Completely clear?
Yes, sir.
Okay, now let's see. We have this structure. I'm not drawing the HH. Okay, let's draw. This is, you can see carbon 1, 2, 3, and 4. It's a cyclic butene, okay? Clear? Got it?
Yes, sir.
Now, what do you think? First point. Is it cyclic? Yes, cyclic. Does it has the, is it planar structure?
Yes,
Yeah. Yeah.
because each carbon
Right.
is sp2.
Third point. Does it haze conjugation? Yeah.
Yes.
See, double single. Yes, it has. This can move here. This bond can move here, and we can have this structure. Okay. Then again, this bond will this one again big. Is it clear now?
Yes, sir.
Last 4 point. Let's see. Huckel rule. Okay. 4n plus 2 pi electron. How many pi electrons are here?
4.
Okay, let's do. So 4 minus 2, 2 by 4 is equal to what? 1 by 2.
0.5.
So do you think it's followed?
No.
So that's why it is not aromatic. Is it clear now?
Yes, sir.
You can see three parameter, three conditions. Okay, it fulfilled the three checkpoints, but one is not complies. That's why you could say it's it's not aromatic. Is it clear?
Yes, sir.
Okay, let's see another one. Let's see another one. Okay. Can you see the structure? What do you think?
It's not aromatic.
Why?
because it does not have conjugation.
Yeah, good. And you see this carbon, this is sp3. Got it? Because it has CO2 hydrogen. Clear?
Yes, sir.
Not planar, so leave it. Any point that you can see directly, leave it. Okay. What about this structure?
It is aromatic
Why?
because the double bond has a carbocation next to it, and
Good.
each carbon
You
is
see,
sp2 and it's
cyclic
cyclic.
sp2 because carbocation is sp2. Is it clear?
Yes, sir.
And conjugation is also there. Got it?
Yes, sir.
And fourth point is what? Huckel Oh, find Huckel. Let's see.
N is equal to 0.
0. Good. So followed. So this is aromatic. Clear now?
Yes, sir.
Good. Yeah. Okay. Now what about this one? This is carbonine, okay?
Not aromatic.
Let's see. Remember, anion is just like a pi bond, okay? Clear?
Yes, sir.
Now let's see. And anion is also sp2. Remember these 2 points. Okay. So cyclic, yes. Okay. Then planar, yes. sp2, 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 sp2. Clear? Got it?
Yes, sir.
Then conjugation. Let's see. Yeah, this is just like a pi bond. So if from here, it can move here, it can move there. Is it clear?
Yes, sir.
Yes. And fourth, Huckel rule. So 4n plus 2 is equal to 6 electron because 2 here, and anion is 2 electron. Is it clear?
Yes, sir.
So followed. Aromatic. Is it clear now?
Yes, sir.
What about this one? What do you think?
Not aromatic.
Yeah, because 4 electron. Is it clear?
Yes, sir.
Okay. Now remember how to directly judge the Huckel rule, okay? If a compound is having 2 pi electrons, 6, 10, 14, 18, 22, Huckel rule followed. Clear?
Yes, sir.
Done. Okay, good. So now we learn one thing. Benzene is what? Aromatic. Is it clear?
Yes, sir.
And you know very well now what we mean by aromatic compounds. Any question in this so far?
No, sir. No questions.
Completely clear?
Yes, sir.
Aromatic compounds are highly stable. Are highly stable. Okay. Now, question always they ask this question: why benzene is stable, or why aromatic compounds are stable? Okay. Is it clear now? Because of what? Resonance. Because of resonance, the aromatic compounds are stable, okay? Because of conjugation, the aromatic compounds are said to be highly stable. Is it clear?
Yes, sir.
Because when compound start reacting, okay, then it's called reactive unstable. If suppose the compound is happy with its own body, with its own structure, okay, then you can say that it's not reacting, so it's stable. Why it is stable? Which thing gives stability to benzene? These pi electrons movement, okay, within the molecule. They are enjoying with themselves within the compound. These are siblings, okay? They are happy. Electron move from one place to another place. So they are keeping their pi electrons busy within the molecule, okay? So that's why this is called conjugation or resonance. So because of resonance, because of this conjugation, aromatic compound